So tell me, how did you first get interested in space?
That actually is a lifelong passion, and I think that starts with a lot of kids. They always say they want to grow up to be astronauts. I remember specifically, I used to live in Florida. My parents were in the military, and we were stationed out just at Cape Canaveral at Patrick Air Force Base. And my dad always made a point of taking my mom, sister, and I out to the Cape to watch the shuttle launches. And I think just the image of the shuttle launching for the first time and my dad really explaining what I was seeing. These astronauts are blasting off into outer space and here's what they're gonna go do. And I just thought, that's really cool, you know, can I do that? And he said, yeah, you can do that. So ever since then, all my school projects have always been somewhat space related. I'm always asking my teachers about how does this relate to space and can astronauts do that? And throughout growing up all through school, I just never strayed away from that dream. I was always keeping my eyes in the sky, you know, that's what I want to do. I want to be an astronaut, I want to be an astronaut, and never looked back.
So how did you eventually end up start working in space?
Well, I was very fortunate. I went to school, got my degree in environmental engineering, and I knew I always wanted to come work in the space industry. Didn't know how that was going to happen, but that was what I wanted. And I got very fortunate in that about 3 months after I graduated college, I got an interview for a contracting company that I had applied for. Didn't know much about how the world of contracting companies worked and just kind of stabbing in the dark. Sent in an application, got a call for an interview, and they said, hey, this is what we do for NASA. And I said, that sounds fantastic. You got me at we work for NASA. Pretty much from there, I was like, okay, I'm hooked. So yeah, I got an interview, and 3 months later, I was very fortunate to have gotten a job just 3 months out of college.
So what company was it that you started working for?
First company I was hired by was a subcontracting company called GHG Corporation, and they contracted to SAIC, which works directly for NASA. And since then, I've changed badges, changed careers, and, well, not careers, but job titles. And currently, I work for a company now called Barrios Technology.
And what is it you do for them?
Right now, I am a visiting vehicle engineer, which basically means, very simply put, I pack the spaceships. So any of the Russian spaceships, the European vehicles, SpaceX, for example, all of them, we're in charge of the cargo that comes through there. So food, science experiments, widgets, gadgets, anything that needs to go up into outer space needs to come through us. And so we make sure it's packed correctly, it's safe for use, we've got the right number of it. We're not going to run out of food because we packed too many science experiments or we have too much food, so we can't do any science experiments now. So it's a balancing act and trying to find everything to fit harmoniously to go up into outer space.
I hope you played a lot of Tetris.
Simply put. Yes, actually, it's very much like a game of Tetris, which the game I was not that good at. I hope I'm better at this job than I was at that game.
So what have been some of the most interesting payloads that you've had to deal with?
Payloads specifically, that was actually my first job. I was a payloads safety engineer, payload safety engineer. And that was really neat because that was strictly dealing with the science experiments that were going up there. Some of my favorites were, there's this one called ABRS, Advanced Biological Research Station, and they grew willow trees in outer space. They wanted to see exactly what it was, I guess, that made a willow tree grow the way it does. And then another one we flew up was called the Mouse Habitat or the Mouse Hotel. And so we flew 6 little white mice up there. They had their very own space chamber. They just went out and hung up for a couple of weeks, and it was to help study the effects of zero gravity on bone loss. So it was kind of part of an osteoporosis study. And so those were some of my favorites, but I remember a lot of them, they would come through and I'm reading about how this experiment works. And I just remember thinking, wasn't there a Star Trek episode on this? I feel like this thing should be powered by some dilithium crystal, you know, something like that. I said, these are crazy. I didn't even know we were flying this stuff up. And so it's fun now when I tell people, you know, oh, what are they doing up there? Well, let me tell you. And some of the applications that they're going to come back down and have here on Earth, it's going to be amazing. So that was really a lot of fun to see those.
What are some of the applications, at least, that would be more impactful to the general public that have been done so far?
Right, and that's the problem that we run into a lot of times is they're doing somewhat vague and obscure science experiments that a lot of people don't connect with, but one that is very prominent is the research in vaccine that they're doing on the space station. So they're doing one with MRSA, which I don't know what it stands for, but as I understand, it's a very virulent infection, bacterial infection if you get that. They're doing another one with, and the word escapes me now, but E. coli studies, there we go. And we're finding that in outer space, a lot of these bacterial strains are a lot more virulent in outer space. They behave differently, and they don't respond to traditional vaccines like they would here on Earth. So if we can figure out how they tick, we can adjust our vaccines so that we can get better, stronger vaccines, perhaps ones that the bacteria can't become immune to and then overcome, because I know we get a lot of problems with that for things like pneumonia. Sometimes you can get vaccine-resistant strains of pneumonia. So a lot of vaccine and pharmaceutical research is being done, and those are the ones that are kind of the most obvious and beneficial impact to our society.
So for those who might not understand this, what sort of benefits can you get to developing new vaccines and the rate of progress that you would get in microgravity as opposed to here on the ground?
Well, that's a very good question. One of the ones that I really like is crystal growth. So if you know anything about crystals, if you ever did the sugar crystal experiment when you were a kid, you know you have to mix it up and let it cool, and over a course of days crystals grow. Well, here on Earth, because of gravity, you can't quite get perfect crystalline structures. You can get close, but not perfect, because you've got a lot. You've got gravity, you've got temperature going on, varying factors. But they have found that if you remove gravity and put it in a very controlled environment in outer space, we can grow almost near like 99.9% perfect crystalline structures. And so that'll do things like allow us to make better vaccines that work better with maybe less negative side effects, because we can pinpoint exactly how we need this to work. And the same token, a lot of technologies will spin off from that, like supercomputer chips. Silicon crystal growth is a big one up there. Actually, we get a lot of nanocrystal experiments because we can get the signal so refined with these perfect crystals up there. Again, it's like something right out of Star Trek, you know? And so those are a lot of the big studies. And going back to the pharmaceuticals, if we can remove maybe a lot of the negative side effects, because we can get a perfect combination growing up on station, and then we can just harvest that and bring it back down, it'll probably be better than something that we can whip up in a batch in the back kitchen.